Hi everyone and welcome to Ball Python Breeder UK. In today's video we're going to take a look at my Ball Python Morphs guide, which you can find on the homepage of my site, but I've also added a link in the description. So the guide is it's not really a guide to Ball Python Morphs as like a list or the names of all of them. It's really more of a guide to help you understand the main types of genes behind Ball Python Morphs. And the aim is for you to understand each type of gene so that you can make your plans and calculations in your head without having to go to a morph calculator online each time. So first off, before we get into it too much, let's just define what a morph is, because this is a question that comes up quite often actually. A morph is any animal that has an aberrant appearance. An aberrant means differing from the main population. So a melanistic animal is a morph just as much as an albino. A snake with reduced pattern or unusual pattern, like you find a lot in milk snakes, is an animal, is a morph as well. And then line-bred animals that have been bred to look darker, like the dark night leopard gecko, for example, are also morphs. So basically any animal that looks different is a morph. Where ball python morphs differ from a lot of other species is that they tend to be really just linked to three main genes. You don't see line-bred morphs in ball pythons, and a lot of people have tried. So those three main genes are recessive, dominant, and incomplete dominant, which a lot of people still call codom. But before we get into each one and take a quick look, let's just go over a couple of terms. Well, a few terms actually, because genetics is complicated, but I'm going to try and keep it simple. So homozygous means an animal with two alleles for the same trait. In recessive animals, that gives you a visually expressed gene. Like an albino is homozygous for albino. Heterozygous means an animal having two different alleles for the same gene. In that case, whichever allele is dominant will be visually expressed in the animal. So a heterozygous for albino animal would only have one albino gene, and it just looks like a normal, but we'll get into that in a second. An allele itself is one or more forms of the same gene. So two people can carry the same gene, or two animals can carry the same gene, but have different alleles of that same gene, and that can make their eye color different, their hair color different, their whatever different. So alleles are usually limited to a few, but there could be a dozen or half a dozen in some types of genes and stuff. And they occupy the same place on the chromosome, so they're like little things that can be switched. But now we've gone over that, let's take a quick look at the recessive genes first. Now, recessive genes get their name from the fact that, as I've just explained, when an animal has only one copy of the gene, it isn't visually expressed. So basically it goes into recess. It's disappeared for a generation, and that's why people always say to you that recessive genes skip a generation. So I've got a couple of photos here just to take a quick look at that and show you how that would work in a real pairing with real animals, using photos rather than just, the old textbook XYZ, etc., etc. So let's take a look at those and then come back. So what happens when you breed an albino to a normal ball python is all of the babies inherit one copy of the coloration gene, let's just call it that for now, from each parent. So each baby gets an albino gene, A, from the albino, and a normal gene, N, from the normal, meaning the babies have two different alleles, which we call heterozygous. And what happens here is the normal gene is actually dominant, like the dominant genes I'm going to explain in a minute. So all of the babies are heterozygous for albino, but have that dominant normal gene, and they look just like a normal. Now when you go on to this next photo, we're going to look at what happens if you took two of those heterozygous babies that only have one copy of the albino gene and pair them together. And what you got here is a case of genetic recombination where the odds are a 1 in 4 chance of one baby having both of the albino alleles from one of their parents each. So in a nutshell, what you get is 1 out of 4 on average. Remember, this isn't for certain, this is just odds. 1 out of 4 of the babies will be a visual albino having 2 copies of the albino gene that we call homozygous. So now we've discussed recessive genes, let's take a look at dominant genes. So dominant genes are different to recessive genes in that anytime they're present, they are expressed visually by the animal, 100%. And some dominant genes in the hobby include pinstripe, leopard, and acid confusion static. Now, what you'll notice about them is that they have a big effect on pattern, almost always. I think spider's actually dominant as well. But they have a big effect on pattern and less of an effect on color. So often you get the best results mixing dominant genes with incomplete dominant genes that we'll look at in a moment. For example, lemon blast is one such morph. And what I would say about dominant genes as well is to remember that you don't get a super form. When anyone talks about supers, that is to do with incomplete dominant genes, so we're going to look at that in a second. But first, let's take a look at a photo just to give you a quick example of how dominant genes work. Dominant genes are the easiest genes to understand. They are really simple. Dominant genes are dominant over the normal gene for coloration. So when you've got a pinstripe with 1 copy of the dominant gene, it's a visual pinstripe. If you breed that pinstripe to a normal ball python, roughly, remember it's just odds, roughly 50% of the babies will carry that pinstripe gene and they will be visual pinstripes. And that is how it works for every dominant gene. There's no supers. If there is a pinstripe with 2 copies of the pinstripe gene, which would be a super if it were a different type of gene, then that simply gives the gene to all the babies and they all look the same as a regular pinstripe, except for they're all dominant over the normal. So last but definitely not least, we have the incomplete dominant genes. Now when people say co-dom, what they actually mean is incomplete dominant. It's just 2 different terms. People decided that one wasn't correct. Well, geneticists decided that one wasn't correct. So now the term we usually use is incomplete dominant. But as a hobbyist, you need to know that when people say co-dom, it means the same thing. And incomplete dominant genes work exactly like dominant genes. So they have that pattern of showing up in 50% of the offspring on average. And anytime a snake has just 1 copy or it's heterozygous with that gene, the gene is visually expressed in the babies. Now, where they differ from dominant genes is that they have a superform. And the superform acts kind of like a recessive. But basically, if you get 2 incomplete dominant gene alleles present in an animal, it creates this superform. And that is something that we're going to take a quick look at in the photos. But just before we do, this is a great example of an incomplete dominant morph. This is a butter pastel, and she is absolutely beautiful, and she's cheap. And this is why incomplete dominant genes are so important. This is the kind of color and pattern they can add to any kind of combination. So, you know, when you get it into clown, piebald, anything, it just makes it better. And that is why you'll notice that a lot of the main genes in the hobby are incomplete dominant. So pastel, cinnamon, black pastel, enchi, gravel, yellow belly, fire, orange dream, asphalt, and probably, you know, 50 to 100 others are all incomplete dominant genes, and they are kind of the backbone of the hobby. I mean, most people started out with a pastel, back in the day anyway, at least. So we're going to take a quick look at a couple of photos there and see how these work in pairings, just to make it nice and simple. I've done it with some actual snake photos. Incomplete dominant genes work a little bit differently to dominant genes, but they are, broadly speaking, very similar. So when you breed a pastel to a normal ball python, the pastel gene is dominant over the normal gene, and because babies only get 1 gene from each parent and it's at random, roughly only 50% of the babies will inherit the pastel gene, but any baby that gets it will be a visual pastel, which is really interesting when you get expensive new incomplete dominant morphs, because you can make a lot of money quickly, but also the prices go down. Obviously it doesn't stop there. Now when we look at the second photo here, this is how incomplete dominant genes are different from dominant genes. If you pair two pastels, which are heterozygous, they've got one pastel, one normal gene, you pair them together, and roughly 1 in 4 of the babies will be a super that has 2 copies of the pastel gene, and that super form acts a lot like recessives. So you get a super pastel, which looks, frankly, a lot cooler than a pastel. It's brighter, the pattern's more enhanced. That's a really weird example I've got there, but I pulled it off the internet, so make one yourself and it'll probably be better. But in that same pairing, because of the odds, you'll get roughly 50% will also be pastels, and only a quarter will be normal. So pairing incomplete dominant morphs together is a really interesting way of getting completely different looking snakes. So in conclusion, I've done this guide really with the goal of giving you the opportunity to quickly learn about the main genes involved in ball python morphs, so that you can just do calculations in your head anytime you need to when thinking about your breeding plans. And this is particularly useful if you're at a reptile shop or an expo, or you meet another breeder and they say, hey, I've got this for sale. Maybe you don't have good, internet reception wherever you are, but they can tell you what kind of gene it is, and you can quickly do the maths in your head and say, you know what, that will work with my projects, or kind of predict on your own the outcomes of possible projects. And likewise, you can be sat on the sofa with your partner pretending to watch a movie, and you can actually be thinking about snakes and making your breeding plans in your head. So as I always say, if this has been useful information to you, please do like and subscribe, and come back every week for more.